Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over how to factor polynomial equations. Alright, so the instructions are for us to factor completely. Question number 1. What if we have the polynomial equation x to the fourth plus 4x to the third plus 3x squared plus 12x equals 0. Now the goal is to factor this equation completely. So first thing to do anytime you're factoring is to inspect every single term and ask yourself, is there a greatest common factor that I can extract from every single term in the original problem? So let's take a look at the coefficients. We have 1, 4, 3, 12. There isn't any common factor there. But if we look at the variables, we have x to the fourth, x to the third, x to the second power, and x to the first power. Now they are all variables of the same variable with varying degrees. In that orientation or configuration, the smallest power is normally the GCF. So we have 4, 3, 2, 1. There's a 1 here. So the GCF is automatically going to be x to the first power, because x to the first power evenly divides every single variable term here. Okay? So what we're going to do is factor out that greatest common factor, which is x. Now this is the deal. Whenever you're factoring out the greatest common factor, what you're doing is you're dividing every single term by that greatest common factor that has been factored out. Okay, so what we're doing in essence, you don't have to write this down, is we're dividing every single term by x. We're going to have a reduced form of this, the left side of this equation, because we just took out the greatest common factor. Now when we carry out that step, we're going to be left with x to the what power. Now remember, anytime you're dividing exponents of the same term, let's say you have x to the m power divided by x to the n power, there is a property of exponents known as the quotient property of exponents. It says that whenever you divide in exponents of the same base, you subtract the exponents. Okay, so that's what we're going to do here. If you take out x to the first power, from x to the fourth power, you just subtract 1 from 4, you end up with x to the third. Okay, plus if you factor x from 4x to the third, you end up with 4x squared plus 3x plus 12. Okay, now let's take a look at the quantity in the parentheses. Now what we have in the parentheses is a cubic polynomial with 4 terms. So how do we proceed? Since we have 4 terms, that gives us a clue to factor by grouping. Okay, so we'll divvy up the terms by 2, place our partition to the left of the middle sign, and then we'll ask ourselves, is there a greatest common factor for the 2 terms to the left of the partition? And the answer is yes. Let's bring down this x. The greatest common factor between x to the third and 4x squared, look at the exponents. The smaller is 2, so we automatically know it's going to be x to the second power. Now when we factor out x squared from these 2 terms, it's as though we are dividing both of them by x squared. We'll be left with x plus 4. Okay? Now we'll direct our attention to the 2 terms to the right of the partition, and we'll ask ourselves the same question. Is there a greatest common factor that can be extracted from these 2 terms? Remember, if the answer is no, you can always factor out 1. Alright? This sign here always determines the sign of the term that's factored out, so you always drop down this sign. Let's put an arrow there. And then from these two terms, the GCF is clearly 3. So we factor out 3, and we're left with x plus 4. Because when we divide these two terms by 3, that's what we end up with. Okay? Now, one way to check to see if your factoring by grouping is correct is by examining the quantities in the parentheses. If they're identical, then that's a clue that you're doing your work correctly. So that's the case here, so we may proceed. You bring down the x. The two quantities in the parentheses that are identical can be factored out to give you x plus 4. And the outsider is the GCFs that we factored out from both sides of our partition will be grouped together in their own little parentheses. X squared plus 3 equals 0. Now the question is, can I factor any of these further? This cannot be factored as a monomial. This is a linear binomial. There isn't any GCF that can be factored out because we already addressed that earlier on. Now let's take a look at this right here. There is a formula called the difference of squares formula. Okay, difference of squares. What is that formula? Well, it's a square minus b square equals a plus b times a minus b. So what this formula tells us is that anytime you have a difference of two squares, it can be factored further. The procedure just involves taking the square root of the first and the second term and expressing them as a sum and a difference. Okay? The question now is this formula, the difference of squares formula, applicable in the factorization of this quadratic binomial? X squared is a square, which is good, but take a look at the sign. The sign is a sum, but this formula is only applicable to differences or minuses, so we may not apply the difference of squares formula in the factorization of this quadratic binomial here. So since none of these terms can be factored further, this is our final result. Okay, so let's go ahead and box that and proceed to question number 2. So for number 2, what if we were asked to factor the expression x to the 4th minus 81 equals 0? Now let's review our squares again real quick. So what is 0 square? 0 square is equal to 0. This basically means that when you take the square root of 0, you get 0. Okay? 1 square is 1. This means that when you take the square root of 1, you get 1. Square and square roots are inverse operations. 2 square is what? 4. This means that when you take the square root of 4, you end up with 2. Let's keep on going. 3 square is 9. That means that when you take the square root of 9, you end up with 3. Okay, so these are some of your squares right here. Perfect squares. Okay, the result that you get when you multiply an integer by itself, you end up with a perfect square. Okay, now let's take a look at this equation that we are supposed to factor. We have a quartic binomial here, and we want to take a look at the two terms. Are these squares? 81 is clearly a square because if you multiply 9 by itself, what's 9 squared? 9 squared is 81. Okay, which basically means that when you take the square root of 81, you end up with 9. So this is a square. Is x to the 4th a square? The answer is yes. Okay, don't forget, any time a variable has an even degree, it's automatically a square. Squares are situations where the power is divisible by 2. If you can divide the power by 2, then it is automatically a square. So that's the case here. So what we're going to do is we're going to apply the difference of squares formula. Let me write it down again here for your reference. A squared minus b squared equals a plus b times a minus b. Okay, so the execution of the steps is as follows. We'll simply take the square root of the first and last term and express them as a sum and difference. The square root of x to the fourth is what? When you're taking the square root, what you're basically doing is dividing the power by 2. Okay? So x to the fourth, the square root of x to the fourth is going to be x squared. Okay, so we have x squared plus the square root of 9, which is the square root of 81, which is 9. And then the same roots, x squared and 9, but this time we have a minus. Okay? So this is what we get when we apply the difference of squares formula in the factorization of the original problem. The question now is, can we factor these further? Let's take a look at the first quantity. Can we apply the difference of squares formula here? Almost, but no. We have a 2 squares, which is excellent. X squared is a square. 9 is a square, but we have a problem. The problem is the sign. The sign must be a negative or minus in order for you to apply the difference of squares formula. So that's a plus. That means that this cannot be factored further, so just drop it down. Now let's direct our attention to the next quantity. Is this a difference of squares? And the answer is yes. X squared is a square because the power is even. 9 is a square because 3 squared is 9. And we have a minus, which makes it a difference of squares. So how do we go about factoring a difference of squares? You simply root the first and the second term and express the roots as a sum and a difference. So we end up with x plus 3 times x minus 3. So that equal to 0. Alright, so that is your final answer for question number 2. Alright, let's move on to problem 3. Now what if we were to factor the polynomial equation x to the fourth minus 11x squared plus 28 equals 0? Now the first thing we're going to do is take a look at all 3 terms of this quartic trinomial and ask ourselves, is there a greatest common factor that I can extract or factor out? And the answer is no. Okay, there's nothing to be factored out here, no greatest common factor. Now we have a trinomial as indicated earlier. So if I can convert this trinomial into a polynomial with 4 terms, then I can proceed by factoring by grouping. Okay? So how do we accomplish that? To convert this into 4 terms, we're going to make use of the x game. Okay? We're going to put AC on the top and B on the bottom. In this problem, A is the coefficient of the leading term, which is 1. B is negative 11, and C is 28. AC is 28, and B is negative 11. Okay, so this is the x game. So we're going to ask ourselves, what 2 numbers multiply to give you 28 and add to give you negative 11? Okay, so we have 4 times 7 gives us 28. Now the signs don't work. How about we negate both of them? So negative 4 times negative 7 is 28, and negative 4 minus 7 is negative 11. So that's perfect. Now we're going to rewrite this quartic trinomial in the following fashion. X to the fourth minus, let's change that color there, x to the fourth minus 4x squared minus 7x squared plus 28. Okay? Now we have 4 terms, which is excellent because we can now factor by grouping as we did in problem number 1. So we're going to Split our polynomial down the center. From the first two, we extract the GCF, which is x squared, and we'll be left with x squared minus 4. From the next two to the right of the partition, we'll extract negative 7, and we'll be left with x squared minus 4 again. Notice every time you factor out a negative, the sign of each term changes. This was negative before, became positive. This was positive, now it's now negative. The two quantities in the parentheses are identical, which is great. So we factor them together. We have x squared minus 4. And the outsiders, x squared minus 7, are grouped together in their own parentheses. Okay, x squared minus 7 equals 0. Now the question is, can we factor any further? So if you take a look at the first one, we can clearly see that that's a difference of squares. If we apply the difference of squares factorization technique, you root the first and the second and express it as a sum and a difference. You have x plus 2 times x minus 2. And then x squared minus 7 is almost a difference of squares, but 7 is not a perfect square. So that cannot be factored further. We just drop it down as x squared minus 7 equals 0. And there goes your final result. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your study of polynomial factorization, do give us a thumbs up. Your positive feedback is very important to us. If you have any questions or comments, just place it in the comment section below, and we'll be more than glad to respond. Don't forget to subscribe to our channel for updates to other tutorials such as this. More clips can be found on mathgotserved.com. Thanks again for watching and have a wonderful day. Goodbye.